morning. Good morning to all. Good morning, all of you. Right. Am I audible to all of you? Rahul is there? Rahul, am I audible? Okay. Uh,
Audible, sir.
yeah, nearly 50%. Audible. Okay. Nearly 50% of you come. Others will be joining shortly. Okay. Right. Actually, in the second unit, I taught you definition of process. Right. How to determine definition of process. I taught you in the last class. Right. Here I told you twice you have to analyze the trust by method of joints. Okay, given trust, you have to analyze it twice. Okay, what is meant by analysis? First step is you have to determine support reaction, and then you have to determine the forces carried by all the members of the trust, right? For the given load. Once you have to analyze, again you have to analyze the trust for the unit load, dumping load, okay, applied at the joints where dimension is required. That too, in the direction in which the dimension is required. Okay, so it is required to analyze the truss twice, right? For that, you should be very strong in method of joints. Concurrently, you have to do method of joints. Actually, strictly speaking, this unit is over already. Second unit already I have completed. Okay, only last class itself I completed your second unit. How to determine definition of process I completed. Today I thought of starting the third unit, energy methods. Okay, but spending only one class for this second unit may not look good. Okay, so what I have decided, since majority of you are below average student, so most of you might have forgotten the method of joints which you have studied in the last semester. Okay, so today what I have decided, I want to teach you method of joints once again. Okay, the lecture which you have, the subject which you have learned last semester. Okay, method of joints. How to analyze a trust by method of joints. I want to teach you once again because it is the wish of majority of you, majority of students wish, because most of you are below average. That's why it is better. I feel it is better to review the method of joints once. For that, I am not going to teach freshly here. What I have decided, I will replay because the recorded videos are available. Last semester, I taught you how to analyze trust by method of joints. That recorded video is available with me, right? So I will replay it. Just I will play it here. I hope you can hear it. In case if you face any problem, let me to know. A slight echo may be there, but kindly bear with that. The audio problem may face little, not much. Okay, but it's clear only, I think. Right? I will go to start playing this one. Right, 1 minute. This is the lecture video. I handled the okay. 1 minute, 1 minute, 1 minute. Yeah, but I cannot. Yes, let's see here. Right, good. So this is a video. Right. Where is that one? What is it? This. Okay, but I will play and then I will minimize it. Right. Just I will play it. Just you tell me, is it audible to you or not? Is it audible to all of you? The lecture talk is audible to you? Rahul?
Sir?
Rahul?
Sir?
Audio
Yes,
வருதா?
sir. உங்க ஆடியோ வருது சார்.
என்னோட ஆடியோ வீடியோ ஆடியோ வருதா?
வீடியோக்கு ஆடியோ எதுவும் வரல சார். உங்களுடைய நீங்க பேசுறது தான் சார் கேக்குது.
ராகுல், வீடியோட ஆடியோ கேக்குதா?
இல்ல சார், நீங்க பேசுறது மட்டும் தான் சார் கேக்குது.
இல்ல, நான் மூவ் பண்ணிடுறேன். நீங்க பாருங்க, இப்ப சொல்லுங்க எனக்கு.
நோ சார், வீடியோ ஆடியோ எதுவும் கேட்கல சார்.
ராகுல், வீடியோ ஆடியோ கேக்குதா?
இல்ல சார், நோ சார்.
இல்லையா?
நோ சார்.
எனக்கு கேக்குது, எல்லாரும் கேட்டுக்கணும்னு நினைச்சேன். நான் செக் பண்ணல, கேட்டுச்சேன். Rahul, is it audible?
No sir, only the PDF is visible sir.
Check பண்ணுங்க. நான் எடுத்துறேன். என்னோட மைக்ரோஃபோன் ராகுல், என்னோட மைக்ரோஃபோனை கட்டி வச்சிடறேன். இப்ப கேக்குதா பாருங்க
சார்.
ஓவரேஜ் பண்ண முடியுமா? வீட்டுக்கு லாக் பண்ண முடியுமா? லாக் பண்ண முடியுமா? அதே ஆடி தெரியல. பண்ணுங்க. ஹலோ, தெரியல.
Rahul, hello?
Yes sir.
Rahul? Audio totally not audible, no?
No sir.
No, actually I checked 2 days back in my cell phone. I played here and in cell phone I checked it. That time I only joined, but it was audible. I verified it's okay. I will do one thing. I will go to the notes. I will teach you now itself. Because many of you have come.
Okay,
Sorry
sir.
for that's why. Just let me to find out this one. The notes. Where is the notes? Few minutes, ma. Actually, last class I played it. Where is the notes is available? Online classes. Yeah, notes is no. That notes I have to find from this. Where did I keep? Oh, but I kept it here. Yeah, here. Yeah, this one. No, right, right. This is the notes. Right. Okay. Right. This is the notes. Yeah, now the notes is visible, no? The notes is visible, right?
Yes, sir.
Yeah, I will teach you now, no problem. Please, all of you recall the method of joints. Here, you have been given a simply supported truss, right? So, what to do? You have to determine, I don't want to come in video, just audio I will teach you, right? Determine the forces in the plane truss supported and loaded as shown in figure. You have a simply supported truss, right, loaded with a 40 kilonewton here, 60 kilonewton at this joint. It is simply supported, and moreover another load 80 kilonewton is acting at this joint, right here. I will go for this hand tool. Okay, here, right? So what happens? First step is to determine support reaction, right? So I have written support reaction. Since it is a simply supported beam, simply supported truss, first you have to determine support reaction. Sigma ME is equal to 0 implies, right? RB into 6. What is that? RB into 6. If the RB tends to rotate the truss, you have to take moment about A. This RB tends to rotate the truss in the anti-clockwise direction about A. That's why RB into 6, a positive moment. Okay. Minus this 40 tends to, while taking moment, you have to concentrate only the point where you are taking moment, and the load under consideration, the truss, okay, as a whole, you have to consider. So this 40 kilonewton tends to rotate the truss in clockwise direction. That's why minus 40 into perpendicular distance from the point to the line of action of 40 kilonewton is here. Line of action of 40 kilonewton is this one. So from A to this is 1.5. That's why minus 40 into 1.5. Okay, minus 60. The line of action of 60 is here, right? So 60 into 4.5 minus 80. 80 is here. Minus 80 into 3. The perpendicular distance is 3 meter. Is equal to 0. Therefore, RB equal to 95 kilonewton. Okay. Sigma Fy equal to 0 implies RA upward, RB also upward. That's why RA plus RB minus 40, because 40, 60, 80 and all downward. Minus 40 minus 60 minus 80 is equal to 0. From this, RA is found to be 85 kilonewton upward reactive force. RB is found to be 95 kilonewton upward reactive force. Okay. Thus, we have determined the support reactions. Next is analysis of trusses, the analysis of truss. You are going to determine the member forces. Assume all members are in tension. Okay, first make an assumption. Assume all members are in tension. It once you make an assumption like this, what to do? Just you mark arrow like this. This arrow should be towards each other, because you have made an assumption that all these members are in tension. That is why the reactive arrow should be towards each other. They are reactive arrow, not active arrow. They are not action, it's a reaction. That's why reactive arrows we have put here, right? Now, member forces, assume all members are in tension. You start investigating from joint A. Joint A means joint A is under consideration. Just you have to draw free body diagram. Just isolate joint A. Okay, just isolate joint A from its supports. For joint A, this member, and this supports. These all three are supports to joint A. Okay, if you isolate here itself, you can draw. Take a pencil and put a circle. Here itself, you can have focus. Just to focus here. That is a free body diagram. You need not draw separately free body diagram and waste your time. Just to focus, just putting a circle with the pencil here and then write down. Applies static equilibrium condition. Sigma Fy is equal to 0 implies F AD, force in the member AD. If you want to resolve it, here it is given 60 degree. Okay, so sine 60. F AD into sine 60, which is upward, right? Plus 85. RA is also acting upward. Plus 85 is equal to 0. We are adopting sign convention like this. upward positive, a downward negative, like that we are summing up. That is equal to 0. From this, force in the member AD is found to be minus 98.15. The minus sign indicates that particular member is in compression, not in tension. That is why 98.15 kilonewton compression. Okay, you underlined. Next, apply sigma Fx equal to 0. I will do one thing. I will just take attendance. Suppose few minutes. I will reduce. I will take attendance, because if you are already very good in method of joints, no problem. If you get bored, some of you can, because those who don't know a method of joints well can follow, attend it. Okay, follow it. That's why I will record attendance for today's class. Okay. Right. Just you listen. Those who are well-versed may get bored, that's why, right? Next, joint B. Sigma Fy equal to 0. Come to joint B. I have investigated this. Okay. Next, I have a similar joint, that is joint B. I am coming to joint B. I am applying the static equilibrium condition sigma Fy equal to 0. So FB, force in the member BE, right? You resolve it vertically. If just to put with the pencil a circle here, right, and resolve it vertically. So FB sine 60 plus 95, RB is 95 plus 95 is equal to 0. Therefore, force in the member B is found to be minus 109.697. That is equal to 109.697 kilonewton compression, because 97 you are getting. That is why it is not in tension, it is in compression. Okay, I have written. Next is sigma Fx equal to 0. Resolve the forces horizontally at joint B. Just take your pencil and put a circle here and only focus here. That is the free body diagram. You need not draw separately free body diagram, just to focus. Okay, sigma Fx equal to 0. So force in the member BE required to be resolved. Okay, I will come to that. Force in the member BC, which is acting towards left. That's why I am putting minus. Anything towards right, I want to write it with the positive sign. Left minus sign. Minus sigma minus FBC minus FBE. Force in the member BE. We resolve it. Okay. So cos 60 is equal to 0. From this, FBC is found to be 54.848. Okay, with positive sign you are getting. It means that member force is in tension. Okay, that member is in subject to tensile force. Okay, that is the meaning of it. Next, which joint you can investigate. Next, you can go to joint D or joint C. Where to go? If you go to joint C, you know force in this member, you know force in this member. Okay, there are other two unknown force member. You can determine. Okay. Otherwise, if you don't like, you can go to joint D also. Because you know only force in this member. Force in this member and this member you don't know. Only two unknown force members are there. Okay, after completing A, B, you can go to either D or C. No problem. Or E, anything. Any joint you can consider. Okay. Because in all the joints only there are two unknown force member. We have two static equilibrium conditions. We can determine those unknown forces. Yeah, okay. Any joint you can investigate next. I want to go to joint D. That's why I have written joint D here. Okay. Resolve the forces. Same procedure. Is it necessary to explain? It will take time. That's why can you revise it? Whether I think some of you you have downloaded the video, no? Better I will do one thing. Shall I send you that video? Can you see the video lecture? That will be better. Okay. I will do one thing.
Yes, sir.
I will stop it now. A few minutes. First, I will stop recording. uh,